Mercury, the closest planet to the Sun, has long been shrouded in mystery, a distant enigma that defied our understanding for centuries. Imagine a world where time twists in impossible ways, where the sun rises and sets in reverse, and where temperatures swing from blistering heat to freezing cold in a matter of hours. This tiny, broiling planet has always been an object of fascination, but recent advancements in space exploration have begun to peel back its layers, revealing secrets that are as dazzling as they are dark. Mercury, once perceived as an unassuming, crater-pocked planet, now emerges as a world teeming with mysteries, from its unusually large core to the possibility of diamonds hidden beneath its surface. What terrifying truths lie beneath those alien plains? So how do these discoveries change our understanding of the solar system? The journey to unravel the mysteries of Mercury began with NASA's Mariner 10 mission in 1973, followed by the launch of the Messenger probe in 2004. The first images of the Mercury's orbit is amazing. They discovered a world just like scientists had predicted, a surface covered with strange craters and bumps reminiscent of our own moon. But upon further reading, it turns out that Mercury is much more complex than one might think. The Messenger probe, specially designed to orbit Mercury, has taken more than 200,000 images, revealing never-before-seen parts of the planet. Among the most interesting findings is the abundance of calcium and magnesium on Mercury's dark side, raising questions about the fate of these elements on Mercury. In addition, the study found that Mercury has a very strong force in the northern hemisphere, unlike what is seen on other planets in our solar system. On Earth, magnetic fields are created by liquid iron moving through the core, but Mercury's unique interior results in different magnetic behavior. Mercury's nature is equally energetic and impressive. During the day, the temperature reaches 800 degrees Fahrenheit, hot enough to melt lead, and at night it reaches 330 degrees Fahrenheit. These large temperature changes occur because Mercury's thin atmosphere cannot retain heat. But despite these negative aspects, recent studies have revealed amazing features on Mercury's surface. In 2012, data from the Messenger probe showed signs of volcanism on Mercury, including signs of an explosion. This discovery challenged the old belief that Mercury was a dead planet. But the most surprising discoveries came in 2020, when scientists suggested that water ice exists in some of Mercury's craters. These craters are so cold that they can hold ice no matter how close the planet is to the Sun. The discovery raises other questions, such as whether normal life forms exist despite Mercury's harsh environment. Mercury's orbit has a variety of mysteries. The planet orbits the Sun in just 88 Earth days, but one day on Mercury, a complete revolution, takes about 176 Earth days. This means that a year on Mercury is only half a day long. If you were standing on Mercury, you would see the rising sun slowly rise across the sky, then recede before continuing on its path. This unusual motion occurs because Mercury's slow rotation cannot keep up with its fast orbit. Scientists believe that Mercury's rapid rotation is due to a process known as tidal lock, where the Sun's force slows Mercury's rotation for billions of years. Unlike our Moon, which keeps time on Earth, Mercury is in a 3:2 rotation cycle, meaning it rotates 3 times for every second revolution around the Sun. This strange day-night cycle creates extreme conditions on Mercury, with one side of the planet experiencing extreme heat for months at a time, while the other side remains in constant darkness. The presence of water ice on Mercury has been one of the most surprising discoveries in recent years. In 2020, using data from the Messenger spacecraft, scientists discovered that Mercury's exosphere, the thinnest atmosphere that still escapes into space, contains more water vapor than previously thought. This water vapor may have come from hydrogen in the solar wind reacting with oxygen in Mercury's surface rocks. In addition, Mercury's magnetic field, although weaker than that of the Earth, is important in protecting the planet from the solar wind, which can quickly remove the thin atmosphere. Despite its small size and slow rotation, Mercury's magnetic field is generated by a unique dynamo effect in its liquid core, influenced by the planet's unique spin and rotation. This weak magnetic field creates unusual features on Mercury's surface, with areas called hot poles, where the sun stops moving through the atmosphere, making these areas extremely hot. More of the world. In contrast, the regions near the poles of Mercury are in shadow all the time, the sun has not yet appeared, and in these regions there is water ice. The geology of Mercury is another area of intense study. For a long time, scientists believed that Mercury was inactive, but MESSENGER has revealed signs of current volcanic activity, including small, bright spots on the planet's surface that appear a volcano. The findings suggest that Mercury is still active in nature, with a complex history that includes strong earthquakes caused by the sun's pull on Mercury's orbit. In addition, Mercury's core plays an important role in creating its magnetic field. Unlike Earth, Mercury's core is mostly liquid, with a solid core in the middle. Mercury's inner core is very large, 1,260 miles long and half the entire core of Mercury. This large inner core may explain the planet's varying magnetic field, which is not centered but is measured by about 20% of the planet's radius. The discovery of nitrogen in Mercury's basement in 2022 is another game-changing discovery. This nitrogen is the remnants of ancient atmospheres forced underground by the planet's intense heat and solar energy. The presence of nitrogen raises interesting questions about Mercury's past climate and the planet's future. In addition, Mercury's thin mantle, which is much thinner than Earth's, affects the movement of heat into the planet, affecting its geological processes. The MESSENGER probe also found evidence of an ancient magma reservoir beneath Mercury's surface, which may have played an important role in forming the planet's surface and interior. This ancient magma ocean may explain some of the unique features of Mercury's surface, such as the large, flat areas known as the northern volcanic plain. Mercury's history is characterized by large cracks and surface faults that indicate significant subsidence during the cooling of the planet. These terrestrial features add another layer to our understanding of Mercury, indicating that it is an evolving planet. It seems that Mercury is still active on Earth, and the Earth is still moving and changing, raising new questions about the inner structure of the universe and how it has changed in the past. Period. Are there other subsurface features, and what do they tell us about the early days of the solar system and the formation of the planets? With the launch of new missions like BepiColombo in 2018, Mercury's mysteries are still being revealed. BepiColombo is expected to arrive in 2025 and take a closer look at Mercury's surface, revealing its chemical composition and Earth's history. The mission will also face the extremes of Mercury's day-night cycle, simulating extreme heat when facing the sun and maintaining energy during long, cold nights. Studying Mercury presents many challenges, but the potential rewards are greater. Each new discovery about the hidden depths of Mercury not only increases our knowledge of this fascinating planet, but also provides insight into the formation and evolution of planets in the solar system. As we continue to explore Mercury, we are reminded that even in our own solar system there is still much we do not know. With its unusual features and complex history, Mercury challenges our understanding of science and forces us to rethink our scientific assumptions. What other secret is there in this small and warm world? Could it change our understanding of the entire solar system? The answers to these questions lie beneath the surface, waiting to be discovered.